in terms of the last lab, let's just go through a couple of things. So, all right, so download this data set. This is the Chicago Crimes data set. Notice one thing I'm doing is I put in this n rows feature, right? This limits the number of rows that we'll be pulling from the data set. I recommend this lots of times. Like, the reason for doing this is our data set was getting so large that just like simple operations in memory were hard to accomplish. So, you can just take a subset of the data and then work with it, and then from there, generally your operations will work fine when you move to the entire data set. Another thing you could do is you could like sample, and say, hey, I just want to sample like 100 records, right? And that will limit you, right? If you look at the shape, then we see we just have 100 records. Okay, so again, like the benefit of sample is, it's a random sample, or at least close to it. So if say you want to get a sense of like what's the most recent and what's the oldest row in your data set, with sample you might have a better shot at that than just taking the ones off the top, etc. All right, so we have this. You can see, I don't know if I talked about shape in the reading, but it just tells us how many rows, how many columns, right? 1,000 rows, 22 columns. For me, typically what I'll do is I'll just also like slice the first few rows of a data set. You can see just like the :3, that works fine. And then I can just, get a sense of what am I working with here. With any data frame, and I think this is one of the main things I saw, was just pay attention to, just like with Python, what is the data structure that you're working with, right? So a data frame is really a matrix of our data, okay? So it's a number of columns, right? Columns and rows. And then a series is just a single column, right? So for a series, we can do like the case number, I guess, or let's do something more interesting with the description, okay? And this is returning a series. And one thing that you can see is that both a series and a data frame have this thing called an index, right? So if I do df.index, it's like a list-like object, very similar to with SQL, right? Where this is kind of how we can access some of our data, right? And a series also has an index, right? So if I can do like .index here as well, okay? All right. So, like I said, just keep in mind like what you're working with. From there, what we can do now, value counts actually, it used to only work on a series, but now I think it works on multiple attributes at once. So we can like copy, oftentimes what I'll do, by the way, to like quickly just get some columns is I'll do df.columns, and then I'll just literally like copy the ones that I think are interesting. So description, location, description, and primary type all seem kind of interesting. So I'll just take them, copy them, and then wrap them in a list, and then call it like columns. All right, and then from there I can do df square bracket, and then remember inside the square bracket is where my columns go. Right, inside the square bracket is a list of columns, and this will return to me, right, a data frame. And then I think I can call value counts on this whole thing, right? It still doesn't look, I don't know. I still don't think it looks so great. Let's just do it on primary type. Okay, so this is better. So it automatically, first of all, what is this returning? It's returning a series, right? The index is actually these categories over to the left, right? So if you ever want to like just get that list, you can do .index and get that. And then just note that like value counts, it's a histogram, right? Remember, we've been like building histograms since the beginning of the course. This is the number of times that theft occurs, right, in this series. Okay, and it's ordered from highest to largest. And then, if you do normalize true, it just divides this by the total amount. you can like, just like any other series, like you could kind of calculate that itself. We can see we have 1,000, and so you can just divide this by 1,000. But we'll just do normalize equals true. All right. Then from there, let's say we wanted to plot the primary type. This is what I was getting to at the end of last class. We can do this in two different ways. One is, I guess we could do a histogram, you know, and say, I normally do it this way. I'll do plot, and then I'll specify kind equals the kind of plot that I want. And we can, I guess I'm lying. No numeric data to plot. Okay. All right, well, let's say this doesn't work. Let's do this a different way. We can take these value counts, and then we'll do plot, and now we'll plot a bar graph. I think I can do bar H. Okay. And here you can see this is ordered, right, from highest to least. Like if we wanted to, maybe we could order it the other, you know, have that flip this. In order to do that, let's just do that real fast. I guess we'll just say sort values, ascending equals true, right? And then do plot kind equals bar H. We can do that. All right, this is a little bit better. So we can see, you know, theft is, and it gives you like a pretty good sense of these. So this is, lots of times I'll use this like bar graph as a way to do this. It just makes more sense to me. And also you can see the results, right, before we actually plot it. You can kind of see these results, and right, these are my, this is my hist, and then we can plot the histogram. Okay. Other things. Okay, so other things to talk about. Group by. I saw this come up actually like a good amount. I'm not sure. Let's take a look and see if there's a good case for using group by here. I mean, we could like group by the year. There's not really an amount of stuff to like add up. So it's kind of silly. It's a little silly to do group by in this case, I think, but we can do it anyway. Let's say we group by the, I wish there was a neighborhood. I mean, the ward might be the closest thing. Well, let's say we group by the, we'll do the same thing. We can almost group by date. It's all right. We'll group by the location description. Okay, so we'll take the DF, we'll do group by, and then we'll pass through the location description. So I always like copying it. And notice this returns, like it hasn't yet really executed at this point because you haven't told it how to aggregate, right? So it's put the records into groups, but you have to say like, all right, do you want to add up the data, you know, or count it or whatever? We can do count, I suppose. And one thing to note is that, and this is, I think I saw this a lot, it's returning basically all the columns that it can, right? So you have to then, from there, specify like which columns you want to select. Like, you know, so if we look, let's look at this originally. Okay, so it's like counting up the number of times, you know, in each group that it sees that it has rows for like, I guess like arrest or anything. It's just giving us the same results each time because it's just basically counting up any of the values that aren't null, right, and showing you them. So the point of this is, if say we had like a sum, like, you know, this is our movies data set and we were grouping by genre and then showing the revenue, right? What you should do is you should select that attribute that you care about. So maybe here it would be like arrest, Okay, and now we have this count of, I guess, the number of arrests in these different locations, and then plot this. Right now we're back to something that makes sense as a bar graph. So we can do plot kind equals horizontal bar graph. So that bar H thing, right? And here, like, this is a mess. So maybe what we'll do is just take 20 of the values, or sort the values, and then show us the top 20, something along those lines. All right, but you can kind of see, oftentimes I'm using the same strategy again and again. Okay, so group by, the point with group by is it's going to return to you a data frame of basically all the columns that it can display to you. Let me just show this one more time. We can do this with the with the movies data set. It might make more sense. So if I have this data set of different, we'll call this movies DF, of different revenue. Let's take a look at this. Right, we have this budget, we have the revenue, right? And now let's say I want to group by the genre, right? This is not really displaying us anything. And then I'll do dot sum, okay? If I do dot sum, it's going to add up everything it can. I think this makes more sense. So it's like adding up the months, right? Because they're numeric. Basically, everything that's numeric is going to take the sum of. So what do I want to do? I really just care about like the total revenue per each of these things. So then from there, you can do revenue. Okay, and I guess I'm wrong. I think I just spelled it wrong. So here we have the revenue, and now we're back to this series. The index values are the different genres. Here we have these, the actual revenue amounts, and then we can plot kind equals bar H. Okay. If you want, you can sort the values, etc. One more thing is, oftentimes I'll pass through a fig size just because this stuff can get long, and do fig size equals. And I always forget which value is X and which value is Y. I always just mess around with it. Let's say 3 by 10. This is the wrong way. Okay, let's do 10 by 3. Right, this is like more reasonable, I think, to look at, just to like see what's going on. So now, we can quickly group our values, add up the revenue, right? Do the sum, then just say, okay, it returns to us a data frame. So select only the revenue column from there. That will give us a series that has the categories and the amount of revenue, and then from there we'll plot that as a bar graph. Okay. So what is the overall point, right? This thing returns a data frame, so you have to select it from there. And then the other way you could have figured this out is just do one thing at a time. Just see what the return value is of this, and you'll see that it's a data frame, and then work on it from there. Other things I wanted to talk about, not too much. I don't know, other questions that came up with working on this? No? I know with, I think with some of it, it was saying, I forget if it was here, it was saying the column arrest, plot a histogram of the arrest column. I think what you had to do, if you take the data frame and then just look at arrest, you had to, I think you could do dot, is it apply? Lambda x, and then string of x. And now, if you look at the D type, this is of type object now, instead of a Boolean, meaning it's like a string. And then, I guess you can plot this as a histogram. Okay. So that was this one. This, as you can kind of see, this is basically just like map, right? This is take each row each element in here and convert it to a string, okay, and then plot that. Okay, so we spent a little bit of time on value counts. We spent a little bit of time on group by. Uh, the only other like method that I'll use, like I said, I'll use this describe a good amount, right? Just to look through the data, and then the other thing, columns, and then the last thing that I'll look at is df.dtypes, right? Just to see, okay, what are my numeric data and what's the data that is not numeric that maybe I can change. Like for this right off the bat, date, right? Seems like it could be changed to an actual date, and we can get more value out of it from there. All right, that was really all I wanted to cover with that lab. Anything else I should go through?
Are you gonna later on kind of talk more about the general idea of data checking and kind of how much you have to check and when you know things are good?
Well, yeah, that's a nice segue
Okay.
into like data representativeness. So, I mean, this is basically, this is the next lesson, which is, okay, we have this data. It's SAT data from New York City schools. And, these different boroughs, I just Googled on Wikipedia, like, what do these abbreviations mean? Because I didn't know. And apparently, this is how they correspond. What I'm doing here is I'm just creating a dictionary. Right, of key value pairs, and then I'm using the replace method to take this column and replace whenever I see M with the word Manhattan, and then the assign method is how you can add a new or replace an existing series with a new series. So I don't know if the readings covered this just real fast. If you look at the DF, this has this has Barrow, and then we'll do DF. What we did was we used this replace method to give us a series, right? So this is a series where we replaced every instance of M with the word Manhattan, and then I'll just do df.assign Barrow. So I'm going to replace this Barrow series with this one up here, okay? One thing to note is this returns to a new data frame. So if you can't just now say, oh, this data frame has been changed. You have to assign it to something and use that. All right, so this is now our updated data frame. All right, or I call it df updated. And now that has Manhattan, etc. So then what do I do is group by the Barrow, say let's get the average, and let's just select, right, the math and reading scores and sort by the math scores. So we group by Barrow. So it's really just 5 rows here once we group by, and we see Staten Island is doing the best, and then Queens, and then Manhattan, and then Brooklyn, and then the Bronx. And the question is, okay, like what can we actually take from that? Does that mean that they're doing the best? And maybe. I can't really remember the answer. I remember the techniques of searching through it, and that's really the main thing. And one thing just to note is doing something like this is not really sufficient, I don't think. Like you can say, show me all the NA values, right? Basically, show me all the null values, and then add them up. So this is NA. Basically, asks every single, value, true or false. Is it NA? And then true is a 1 in Python, right? And false corresponds to 0. So if we do a sum, this will tell us across each column how many missing values there are, how many null values there are. But I think it's a different question to say, all right, does this data set tell us how how well each Barrow is performing, even on the SATs? Forget about just general math and reading. Does this tell us how well it's performing, each Barrow is performing on the SATs? And then how would you go about answering that? Okay? So what I'll do is I'll give you guys like 15 minutes to, I know, I don't expect it to be done in 15 minutes, but just to like go through it, try some different techniques, and then we can go through this as a group. All right. But again, the point is, like doing something like this, I don't think is sufficient, right? Because really, it's not really about like how many times we see a null value. It's, you know, does this data set represent our underlying population, right? By underlying population, I mean that's even tricky in itself. It's either the students or the schools, right? Does it represent that? Okay. All right. So let me deploy that. That's really this SAT prompt. I'll let you all work on that for 15 minutes. And then I'll deploy the reading, and then we can talk about the reading. Okay? So many people are really just stuck in the data set itself in order to analyze the data, right? And if you think about it, like I don't really think you can do that when looking at a data set. I think you have to check like the data against some other source, or like start to go there, or somehow against like the real world, right? Because what happens, right, is you have like the underlying population, right? Like this is actually like maybe every school and the truth of the matter, you know, and how every school performed. And then you have your data set, all right? And if all you do is just kind of like say, well, how many missing values are there across my data set? And let's say we see, you know, this one's NA and this one's NA, but we only have, you know, 100 schools. Meanwhile, there's like, you know, 1,000 schools in the real population. It doesn't matter. like it doesn't really matter that these two things are NA. You're like, that's not really the issue, right? The issue is, wait a second, how did we get from here to here? And like, why, you know, what do these schools look anything like the underlying population? Okay, so that's really like the main thing that I think you have to think about. And that's why I say, like, you kind of have to be curious about it, or just like skeptical maybe is a better word, like kind of like asking almost like annoying questions about the data set when like you really have to think about all the things that can go wrong, right? Because if we're data engineers and we're pumping this data through these different pipes, and all that data that we're pumping through is like crap, it doesn't really matter how quickly we pump it through, you know? And by the way, people care about that. Like, it matters. So, okay. Okay, so how did I approach this? Not saying it's the best, or there's, you know, I'm sure there's other ways. But the first thing I did was just try to, again, like build a histogram and say, okay, if I call value counts and look at the breakdown of, you know, the rows of data that we actually have, how many times does each item show up, right? If you know something about New York, this doesn't seem too bad, right? Because Brooklyn, I believe, like is the most populous borough, you know, and I did the same thing, just plotting it. But I was curious. I was like, crap, we have no Staten Island data. Like maybe that's why, you know, we're just getting very unrepresentative sample. Maybe only the top schools are reporting this. So the next thing I did was just Google, right? How many schools are there in Staten Island and these different places? And it says there's actually only 27 schools in Staten Island. So having 11 of them or 10 of them is actually like pretty similar. Doesn't mean that it's, you know, there still could be plenty of problems, but it's not a lower proportion of the real underlying schools than, say, Brooklyn or other boroughs. The other thing is, the other thing that I looked at, if you look at the DF, let's just look at this thing. You can see the number of test takers, right? And the total number of students. So, I mean, it depends on what conclusions you're trying to make. But if you're trying to look at just performance on like overall math and reading performance and using the SAT score as a proxy, right? Well, you know, it's probably the case that more of the top students are taking the SATs, right? Those with more resources, etc. So, one thing to look at is, okay, what is the percentage of students that are taking the SAT, maybe across all boroughs? So how do you do that? The way I did this was, select the number of test takers. So we'll call this the number of test takers. And then also select the total number of students per school, right? And then we can divide them. So in Pandas, you can divide, say you have this total number of test takers, right? This is a series. You can divide a series by like a number, like 10, right? Or you can divide it by another array, right? So if number of test takers is a series and total students is a series, essentially, and we want to divide the two, it will line these up and tell us, okay, this is 16%. In this first school, it was 19.5%. The second school, so these are the percent of people taking the test, and then from there, we can add this to our DF, our data frame. All right, so that's what. Just add the percentage. We'll call this DF with percent. And essentially the point is, okay, this school, maybe they did, well, but, the only 17% took it. So is it the case that a lower percentage are taking the exam in like Queens versus Brooklyn or Staten Island? The way to do that right now, we can group by, do a group by the borough, and then do maybe the mean, the average of the average, right? And then select that percentage test takers. And right here, you can see the results is it's actually ends up being pretty similar, right? One thing though is probably this isn't a good, probably in terms of the conclusions we can draw from this, you can really only draw conclusions of a borough, even if we had all the data, about those individuals taking the SAT and not the broader population, right? You only have 15% of each, and the chance that this 15% is representative of the school as a whole is pretty low, I would say, right? Because you'd have people that aren't college seeking, and right, it's a very biased group. Okay, and then of course there's looking at the NA values. We did that, and then one thing I'd say is just so so far what we did was we looked kind of to that first question as to, does our data set line up with the underlying population, right? That was this question. And then the next thing is, okay, the amount of NA values in the data set itself. When you're looking for this second question, you don't want to just look for values that are literally NA, because you can imagine people can encode things like lots of times you'll see -999 or other values that are in order to indicate missingness, or you'll just see nonsensical values at all, right? Values that just don't make any sense. For example, here would be any negative numbers, right? Or any numbers outside the range of like an SAT score. So what you want to do generally is plot a histogram. And for this, you can plot a histogram of kind of like everything, doing the .hist thing. This is typically kind of a mess for me, like just seeing all of it. The main things that you really want to look at though are the target values. I'd say the target values, and then and dates. So for the target values, what we mean is what are you kind of trying to predict, or what are you measuring, right? So here it's like maybe what are the factors that contribute to a good SAT score? So it'd be your reading, math, and writing, right? So that's what you want to plot a histogram of. And so let's just select those two. So reading average. And what I'm looking for is to see, are there values here that say are like -999, or just values outside what makes any sense? so that I should remove them, right? If there are, then I should remove them or handle them somehow. In this case, they look fine, right? 300 to whatever, something less than 800. But one thing you do notice is like there are some outliers here, right? There are some schools that are performing really well. It would be interesting to see, like who is performing well, and then also maybe who is performing particularly poorly, right? One other thing to note is, and this I really recommend, so far we looked at, does our data represent by kind of considering, okay, like what's the break, how many schools do we have? Are we missing some more schools in a certain borough? Test takers per school, so are we missing test takers? We are. How about the quality of our data, right? One thing is like if you're trying to get a sense of how schools are doing today, unfortunately education, things change exceptionally slowly, but you want to look at like when is this data from, okay? So this data happens to be from like 2010, right? So it's old, but the reason why I bring that up is lots of times you'll get data from a range of years, and at that point, what you can do is say, okay, we're only getting 5 records from 2009 and 1,000 records from 2010. You really can't draw anything about 2009, right? You want to select those years generally that are more recent, right, and more comprehensive. Okay, so plotting like year, month data, right, is generally something you want to do to look to see, wait, if it's sales data, how come we're missing 3 months out of the year? What's going on there? Right, as a way to get a sense of the quality of the data. And so the other dimension you generally want to look at, one is the target, the other is date time data, okay? So if you're going to focus on just some attributes, that's what I would say. And then you might say, okay, well, I'm being like so nitpicky. Basically, we can take any data set and say there's nothing we can do with any of this stuff. And that's the wrong, right? I would just say like, that's not really true. So what can we do with this? Well, yeah, it is old, but what we saw was we have some schools that are very high in terms of their scores, and ones that are quite low. One thing we might want to do is look at those schools that have a high percentage of test takers, right? So we can just maybe select that and just see, are there any that has something like that? So if you look at the max, we have one school that's at 97%. Which is like an exceptional outlier, right? We also have some schools one school that's at 4%, also seems bad, right? Like an outlier. So what you want to look at, potentially what you could do is just focus in on this school, right? That is, quite good, and here we do have something that seems pretty representative of the overall population of the school. The other thing you can look at is very low performing schools, either from a percentage wise or from just their actual score, and start to see, okay, like why is that school performing poorly compared to its peers, right? So again, like oftentimes with our data, maybe I can't make a conclusion about the entire borough, but we can, there's just, our data is not complete enough, but we can change the scope of our project, right? And instead start to look at things maybe just at an individual school. We saw that, hey, looking at an individual school in terms of how well they perform is hard because, it could be the percentage of students taking it are very low. So that means that we may just have to narrow in on a couple of schools, right? But bad performance, that's a little easier to look at because the school's probably one student's taking the SATs, so having a low percentage taking it and a low score at the same time, right? That's something you can look at and look at that individual school and start to see maybe why it's doing worse, or any changes in the data over time if we had more than 1 year. Okay? So what are the takeaways from this? I would say is like, what can you do with missing data or bad quality data? You can, one, change the scope of your project, right? In terms of, hey, I can't look at an entire borough, right? I have to look at, an individual school or individual performance students. The second thing you can do is just take a slice of your data, right? Like data from a certain year. Maybe one of the boroughs is more comprehensive than the other, and so maybe we can draw conclusions about, say, data in Brooklyn, but not data in the Bronx, right? Because we have a higher percentage, right? So that's other things that, or just years. Lots of times it's this year we only have data from 6 months, but this year we have data that's more comprehensive and it's more recent, right? So it would make more sense just to select the more recent year, especially if it's more comprehensive. All right, and I've done like, if you, I don't know if you all have ever tried doing like Kaggle competitions, but like we did a Kaggle competition to predict sales in Walmart stores, and they gave us past sales data. So all the students in our class placed in the top third of competitors. And one of the key things we did was we just selected more recent data. Right? They gave us data from like 10 years, and we're like, well, just actually, it turns out that the more recent years are more predictive, and the older years are throwing us off. So that can just that in itself can really be of help. Okay. Questions about this? Right?
Not like
Go ahead.
a
Kyle.
golden rule, like if you have a missing data less than 5%, you just delete it and make a prediction. Why
You have to account for it. I mean, like there's a couple things. Like you have to, one, it depends on what is the domain of the project, right? Like if you're off by that amount, right? Like, it comes down to that issue of, missing data oftentimes does not look like the data you capture, right? There's a reason why it's missing. Whether it's on purpose, generally it's not on purpose, it's just harder to capture, and that correlates with something else. So that 5% can really matter, or you just indicate, hey, we're missing 5% of the data, and it matters based on the domain. Some domains it may not matter, some domains it may, right? And then, like I said, there are sometimes portions of the data that are more accurate than others, and so you can perhaps throw away a portion of the data that's, if you're missing 20% of the data from one year and only 5% from the other year, then less times I would just, in that other, especially if that year is more recent, focus on the data that's only missing 5%. I think one thing you're asking is, okay, if we have NA values, what do we do with that? Like, should we throw away the entire row of data? There are different techniques for that. So like if we do this isNA.sum, let's take a look, right? We can see we're never missing the borough, right? That's easy to look up. We're missing the graduation rate sometimes, right? 5 times, and this college career rate 5 times. And we're missing the scores 29 times. Remember, this is the target. Like this is generally like the item of interest, or in data science land, is like what we're trying to predict. So if we're trying to determine what leads to a higher math and writing scores, and then these are the variables. Like let's say the higher people go to college, the higher the college career rate, the more the better the scores. Okay. With the target, I don't really see a value in I would generally just drop the rows that are missing the thing that we're trying to predict, like the thing of interest, because this is kind of the whole purpose. It's very hard to replace this data. Sometimes with things like the college career rate, if you're like, okay, this is the number of students in the school, and this is the number who attend college, right? These are all different factors that then contribute to, say, a higher math or writing or reading score, right? And so maybe in that case, you don't want to throw away the entire row just because you're missing one component that is predictive of a score. So in that case, what you generally do is you replace the value, the missing value, with the average. Why the average? Because it is the average is the value that is least likely to move your data, right? Is on average less off than anything else, right? And it effectively in a model will do nothing. It's just like adding some bland data that's not going to really move it's going to do as least harm as you can without throwing away the entire row, right? So it is this trade-off of we want a high quality data set. In order to get one, we can always just throw away data, but then if we're throwing away so much data, right, we're left with a small sample size, and we're left with basically that whole problem of missing an entire row worth of data. So that is like the trade-off that you play with. All right, so basically the takeaway is, if it's the target, I typically throw away the row, because I don't really see how it can help me. This was the whole point, is to see what can lead to a better math score. And if I don't know what that math score is, like it kind of, that's the whole game to me. If it's like a feature, meaning something that's predictive of it, then typically what you'll do is you can replace the value with the mean. You can also add a column saying, hey, this, for each, this is kind of, let's just say you replace with a mean. One other technique, you don't have to know this, is you can add another column saying, was this column missing for every single row? Because sometimes, say, that 1/3 of the data where it's missing, that missingness in itself can add some value in being predictive. So you kind of get that what was that this value was originally missing can sometimes help out and give you some insights. But that's a little advanced. All right. Okay. Again, underlying thing is check your data against the real world. I think that's, if there's one takeaway, it would be that. And how do you do something like that? One, plot it. Just plot the distribution of the data. See, does that distribution match the real world? Two, take a look at how recent the data is. So you can plot it by year and then plot a breakdown by month across that year to see, okay, is this data comprehensive at least maybe for 1 year or 2 years, etc. And focus on more recent data if you can. And then three is, plot the target. I typically plot the target because it's the most important column there. And oftentimes missing data can be hidden, right? It can be coded as something -999 or just outside the scope, something nonsensical that you want to replace or be aware of. Okay? Cool. All right, so we have a lab on this. It's with the movies data set. So, and I also have this representation walkthrough. So, work through this lab. Then I'll, happy to deploy the solution. And then the rest of class, I think this actually wouldn't take that long, I don't think. After you're done, say you spend like half an hour on this lab and then 15 minutes on the solution, then we can move on to coercing data, all right? After this, we'll move to really breaking down a data set and exploring and finding insights in it. Okay, so we'll probably get to that next week. All right. Let me open up the breakout rooms. Efficient, time efficient with checking your data sets. Because basically, say you are like a data scientist or data analyst, right? You can always do more. So it's but hopefully adding some structure to this. You can just see how many things you can catch in just 10 minutes or something, right? The more valuable, the more you lean on a data set, the more you want to really get to know it and spend time with it. And people certainly go way overboard, or not overboard, but way in depth. But I just wanted to show you, hey, if you focus on a few things, you can really gather a lot and improve the quality of your data a little bit, just with a little bit of steps. So one thing off the bat is, just note checking your data set has something to do with the analysis, but they are two different steps, right? You're not kind of in the description we said, hey, maybe the budget and the genre can be predictive of the revenue, and maybe it can, probably can to some degree, but that's different than the quality of the data, right? The quality of the data, a lot of it will still have to deal with the time period, right? Movies from 1920 aren't going to be very helpful to us in terms of predicting how much something's going to make today. So, right, even if it's not an attribute that, say, you're going to be using, that's very, very valuable in terms of checking the quality of the data. And then the one place where the analysis really does come in handy, I'd say, is, the revenue, right, the target, okay? So, in terms of checking the data, one, right, analysis is kind of a different step than checking the quality of the data. Two, right, where would you start? probably with like the time period and then maybe the target. Either of them are fine. I'll start with the time period first, and then 3. I saw like maybe one. I definitely one. Maybe 2 people like actually use Google to see does our data match the real world. And maybe y'all did it when I wasn't looking, but like do that. All right, like I certainly did that a lot in my walkthrough of the data, both in saying like, does the revenue line up to what this movie actually made, and are the top movies from this year, do they line up with what the internet says are the top movie, right? This data is not so hard to actually check and get a sense of, okay, how does the real world line up to this data set? And people will, like, the reason why we go through this is a very easy way to impress people, right? We don't have to learn about Lambda functions, right? Like, this is a very easy way to show, like, that you can be a quality data engineer. All right. So the first thing I would do is maybe like just plot the years. And by the way, this data set, I did not like mess this up. I just pulled this off of 538's data set. They put their the articles that they write. This is an organization that does like statistical breakdowns of various things. Originally, it was solely focused on politics, but now it's other things. And you can see like I think as we'll go through this, I don't know how this data set's really reliable for anything. But they used it, and I think you can like very quickly show holes in it. All right.
Yeah, I think the data set needs it's movies that pass the Bechdel test or whatever.
Right. The Bechdel test is like is an assessment of like kind of like the 3-dimensionalness of like female characters in films. Yeah. Right. Like it's like the amount one like level 1 is. And you can see it here. Like there are no female, no female characters talk. And then here it's like I guess they talk but never disagree, and some things like that, right? So like very few pass, but still like okay, well how representative? Maybe it doesn't matter for the purpose of that, but still just like how representative is this data? All right, so let's just get the years. So we can do that with value counts. And let's just select the year and then do value counts. And maybe this is ordered from the most to the least, right? So you can see 106. And one thing you can see off the bat is just like a very serious change in distribution. It's not like they didn't make movies in 1992 or 1970, right? But like, what can we really say about those movies if we only have like 8 or 10? Generally, like in terms of a good sample size, obviously it depends on the domain, etc. But even if it's a random sample, like they literally go through like a booklet of all the movies and just randomly pick them out. Generally, you'd want like 100 is when it just like as a rule of thumb is when something you can draw like the sample size is significant or getting there. All right, so this doesn't. Like these numbers, not only are they older, they just seem they seem too small. Like I don't think we can say anything about movies in 1984 based on the fact that there's 11 of them. Unless these were the top 11 movies, then maybe you could say something. All right. So right off the bat, like I would probably only select movies. We want more recent movies. So if we could sort this in terms of the most recent movies we get. I wonder if I can sort the index. I think what I would do is just plot it. Let's just maybe select the top 10. They want me to use iLook. So we'll select the top 10, and then we'll do a plot kind equals bar H. Okay. So in terms of a year that's, I guess, somewhat significant and recent, 2013, right? Looks pretty good. 2011. I don't know where 2012 is, but 2013 at least looks pretty good. And so that might be a year to choose. Right, we have 95 there. 2012, we have 91. So that's pretty similar. So 2012, 2013, 2014 is similar. So in that range, looks pretty good. And then maybe 2015. So that's what I would do is like probably select movies, and this is going to vary, but I would say like around like 2012, maybe say the 2010s as a nice round number. So let's do that. Right, and we can call these recent movies. Yeah, and one of the reasons why I do this up front is, let's say now I want to plot, right, like a distribution. Like say, okay, if I'm using these years, like are these years some, like we at least have movies from all months? Like that might be another thing to say. If I just do a general plot of my data frame and like look at the month and kind of do it that way, I don't really care about how good my entire data set is, because I'm already just scoping it down to 2010. So if the rest of my data set is crap, but this data is quite good, right? Like that causes me no issues, right? I'm fine. So I don't have to spend time, so the benefit of kind of like focusing on this right off the bat is that I don't have to worry about issues in data that I'm not going to be using anyway. Does that make sense? All right. So what I might do now is just like look at the something from like a pretty recent year, and then just say like, okay, well, how good is movies DF year equal to say like 2015, and select the month, and then just do the same thing. Plot kind equals bar h. And I just want to see like, do we have? That didn't work at all. Sorry about that. This is the. Oh, I want to get the. Oh, I want value count. Sorry about that. Let's do value counts. Okay, so this is each month. And there's not a lot, but we only have 95. And now let's plot kind equals bar h. I just want to see like, are we getting movies from all months, or are we like limited in some way? And we are, right? It seems okay to me, right? I'd expect that, right? The holiday season would have more movies, so that's okay. So you can see, right? How did we kind of focus ourselves? We focus on more recent movies, and then we're just starting to get like take a deeper dive at one of the years that we'll probably be leaning on, which is like a more recent year, and just seeing, okay, how good is any individual year. So this is one thing, is the time period. The second thing to look at, as we mentioned, is the target, right? Again, by first scoping down to recent movies, like I don't have to worry about target values that are poor throughout the entire data set. I can just worry about the ones for data I'm actually going to be using. So let's look at the revenue. And again, I might here, maybe you just plot kind equals hist, right? To just take a look. One thing we notice, right, there's a lot near zero. Now, this data is like a little hard for me to interpret. Probably part of it is just it has outliers. So maybe what we'll do is scope down to values where the revenue is less than, say, like $1 million, right? Just to see how many revenues I have less than $1 million. And that way I can get a better sense of the lower end of my distribution, right? Because this 1.4 billion or whatever is making it hard to get a sense of this. Okay, so we're still seeing, right here we have, this is this is only 20,000. We're still seeing movies less than that range. Let's make it less than, let's remove a 0 here. Right? This is kind of interesting. So we are seeing a lot of movies here. So that's what I would look at next, because this could be bad data. I don't know what this is. So let's do the revenue, and then sort values, and I'll sort it ascending. Right? So I'm going to look at all of the... I messed that up. Oh, and I'm doing this. Sorry. So I we'll just select the revenue. We'll do sort values, so we get a bunch of zeros. Let's look at like the top, like 30 or something. So again, there's a bunch of zeros. If we look at the top, and we can probably at this point filter out, let's say the ones that are zero, we're gonna remove. We could take a deeper look at them. I guess we can hold on to them and see if there's anything we can do with them, but we could also just remove them because again, this is our target, and the only thing we could do with the target is probably just Google the actual amount it made and replace it, or we could check to see like, do one of these movies actually make $0, right? So let's just select these movies that make 0. We'll say 0 rev df. Take a quick look at these, see if this makes any sense. So Evolution, I mean, these don't sound like blockbusters, but we can maybe quickly Google how much money did this make, because it says it made 0. Oh, it made 734,000. So one thing, maybe this is because it's an international movie. I don't know that it's having a hard time get it, but this is inaccurate is the point. So it's not data that we can lean on, right? So we can, remove these, I think. So we'll just say take.
So it's not better at this point, like we select only that year which has a revenue which is not equal to 0. For example, 2016 has only 45 movies, but its ratio for 0 is very less.
Okay, yeah, so we can see that, right? Like, if we take, these are, recent movies, non-zero, right? So now we'll filter out those that have 0. But still, what I would want to do at this point is take another look at the revenue. I want to see, we don't have any negative values, but do we have values that are less than, say, like 1,000? Let's just take a look at this still. Sort values and ascending, and let's look at like the first 20 or so, and you get these numbers: 6,000, like less than $10,000 that these are making. You'd want to check this, I think. I think I can do sort an entire data frame by this one attribute. Right, so this is the Adventure Curse of the Midas box, and again, I would just Google this and see, does this movie actually make, like, should this be multiplied by 1 million? I don't know, or 100,000. And let's take a look. Revenue. Nope, it actually only made that much money, right? So like, this is accurate. It just bombed. Some of these later on, I think these are accurate, but this is something I did, right, was to look at these. Food Fight is another one. This only made $73,000, right, even with a budget of $65 million. All right, so this looks, so now we're getting to at least, it seems like, more accurate data, and you're right, at this point, what we could do is you could, again, kind of look at, do a value counts of this data to see how does it break down by year. And now we have, 2016, right, we're down to only 45. 2015, 2014, this seems a little bit better, right? 2013 through 2015 is a little bit better for us. So maybe we'd focus on just like these 3 years. The other thing that I would do at this point now is, again, compare against the real world. So we're going to hold on to 2015 data and throw out 2016 because it seems like we just don't have enough. Let's take a look at those movies, from the year 2015, and just see, and maybe we'll sort values by revenue from most revenue to least. The idea is, like, I don't, with only 76 movies, we don't expect that we're getting a comprehensive list of movies, but maybe we're getting the top movies of the year, right? At which case, we'll limit our population. We'll say, hey, this only describes, the top movies, but, here's what this says about the world or whatever. So we'll sort values by revenue. We can do ascending equals false, right? Because we want to go from highest to least. And we see that we have Jurassic World, Furious 7, Avengers, Spectre. Let's look at maybe 15. All right. And what I did at this point was I Googled the top 15 movies. I still saw that they were missing, I forget which year, but for a good number of years, they were missing like a few movies pretty quickly. So it made me just question the quality of the data set in general, honestly. These values were accurate. The revenue, I did Google these, and these were accurate, but it seemed like they were still missing a good number of rows. And like a quick Google search was able to give me a more comprehensive list of data. I wondered why they didn't just use that. So this is kind of what I wound up with, was I was like, I would probably just scrape the data myself, honestly, rather than use this data set and use Pandas, read HTML to quickly scrape some data. But you could quickly kind of see, at least for me, just by looking at these attributes, that we're not, one, we don't have a lot of data to look at, and then two, when I was like, okay, let's just work with 76 rows, and then I compared this against the real world, there last times we were still missing those data. It's like we didn't even have a comprehensive list of like the 30 most important movies, is what I found, at least. Right. I don't know what you all saw. Okay, but just to review, like things that, how we spent 15 minutes, right, doing this, and we were able to get a sense, pretty, I've seen this before, but not too much. And really, like, we just focused on a couple things. Focus on the year, right? We did a breakdown by year, and we saw that, by doing value counts, we're getting some, like, 3 records from 1940. That's pretty useless to us. We can't draw any conclusions about that year with only 3 records, and we don't care about that year because it's too far away for this purpose. And then we took a look at, so we looked at that, we were able to narrow down to just a few years. Then we looked at our target, right, which was revenue, and saw some poor data. And then probably, I think that was a good idea to relook at the, at the year breakdown and see, okay, that really eliminates some data for us in 2016. And then the third thing, right, if we looked at the time period, we looked at the target, the third thing is keep looking at the real world, right? Check to see, like, is that revenue, are those revenue values accurate? Okay, cool, those values are accurate. Is this list comprehensive? Even if we're gonna narrow down, what our report's about and say it's only about the top movies, do we even have the top movies from 2015, right? And I forget top movies 2015. Here, I think this is what I looked at. Box office, Mojo. Right, American Sniper, I don't remember. Was Star Wars there? Star Wars isn't there. American Sniper's not there. Right, so even with that, this is why I was like, maybe I'll just read this, see if I can scrape this data and use that. The values I think were accurate. Jurassic World 650. Oh, maybe this is there. I don't know. Maybe this is worldwide. I'm not sure, or maybe it's off. But I did look at those values. I thought they were better than that. I don't know. All right.
You might be measuring like the amount they're making like years after the release of Jurassic World, so like the continued amount of money that it's been accruing.
Yeah.
Yeah,
I mean, yeah, certainly. I thought that I looked at others and I was like, this was the amount to me, but I don't know. One other thing I just happened upon, and I think this is probably a good thing just to do in general, is look for duplicate data in the data set. So I'm not sure if there is in this subset, but let's go back to the original data set. How can we look for duplicate data? Just do a value counts of the title. and you look, we can see that we have. I mean, this one might be because it's 2 different years, but these seem like repeats, right? This might be a remake, this first one, but the rest are like, I wasn't expecting to find this, but yeah, there's a good number of repeat data, and how you can get rid of this is just, you get a list of these and remove them, filter out, we could just turn this to the index and then only do a .loc and just select these ones. So we could say where this value count is less than 2, and just select these. Is that gonna work? I can't remember. I can't remember. But anyway, this actually surprised me, right? And so I ended up removing some of this data as well. All right. So this is a quick way to look for duplicate data. Is just look on something that should be unique and call value counts on it. All right. Okay. So that's really, hopefully one other thing you could see is like the amount of quality data that you get can be pretty small. And this was supposed to be from an accurate, like 538. I would have, I'm a little disappointed in them. I thought it would have been better. But, so that's, like, chances are if you put some time into it, you will get value out of checking your data set. And be able to be like, okay, this is what we can rely on and this is what we cannot. So, and then the final thing is, all right, well, this just shows you how little good quality data we actually have here. So one thing, next to do, I'll deploy the solution, but also just work on coercing the data that we do have and making good use of it. As we'll see, the main technique is basically going to be, we have data that is strings that we can coerce into higher value data, right? So we talked about that. This is our Chicago crime data. Basically, a quick thing to do is look at the data that's of type object. A lot of times what I'll do is there's this select dtypes method. You just select those that are of type object and then do .columns or .dtype. It's fine. Dtypes. And then we can see, okay, this is probably fine of type object. This is not. And then from there, what you can do is just coerce this to a date time. The reading shows you how to do that. And then finally, the last thing the reading shows you to do is when you get this data, like the process is typically for coercing data, change things to numbers that can be changed to numbers, change things to dates that can be. Then once you change this to a date, I'll give you a method called add date part. And what that will do is break this one date into like 7 different columns that will be added to your data frame. That will be, okay, here's the month, here's the year, or here's the day, here's the year, here's the time period. Why? Because this way you can do a quick, grouping by year, like we just did previously, and see a breakdown by a distribution of the years, or across months or across weeks, right? And like I said, a lot of this data is seasonal, so being able to do that analysis quickly, right, is very valuable. So I'll just give you that method. But that's really what we'll do with coercing data is change as many things into numbers as possible, change or date times, and then once we get it to a date time, change it to break it out into like those multiple columns with that method. All right, cool. So I deployed this. I also deployed this solution, which kind of goes through what I was talking about. So I would say look at that, and then I think we should try to get through this. Maybe I'll give you more time, but I think you probably can get through this by the end of class today. It's not so bad.